All right, ladies and gentlemen, thank you for flying air math on this beautiful day. Today, we're going to be jumping ahead. You may have noticed that we're skipping 6 for now because we're going to add and subtract polynomials. I'm going to combine like terms to simplify polynomials. So clearly, we have a couple things in there that you'll need to know. We need to know what a polynomial is. We need to know what simplifying looks like. Some of you might have even forgotten what like terms are, which we'll cover all today. But first, by way of warm-up, if you recall how to add and subtract, we always did this. And take a pause for a second. Why is this wrong? Talk about it real quick. Go. All right, so as explained, this does not work because this is my ones place, and this is my ones place. Or another way of saying is my decimal is after the 7, my decimal is after the 4, but they're not lined up. They need to be lined up in columns. So when we do set it up, 1, 5, 4 goes here, but the 7 goes under the 4, the 8 goes under the 5, more like this. So that technically, officially what's happening is that my decimal, which I don't need to show, my decimals are lined up. That's the easiest way to say it. Decimals are lined up. And now, of course, we just add down. 4 plus 7 is 11, so we carry the 1. And 13, so we get 14, and we carry the 1, so 241 is my sum. Similar thing happens over here, 447, and we need to subtract 88. Old school thing. 47, thank you. I need to borrow right here, so we borrow from there. So I get 17 minus 8 is a 9. Of course, I need to borrow again right there. So I get 13 minus 8 is a 5, and bring down that 3. So 359. There we go. Lastly, 4 cats. 4 cats. 11 cats. Then we have 9 dogs and 13 dogs. So notice that if we start to just move things around and line them up, it is essentially what we have is 13 dogs here and 11 cats over there. And now we can add them up because it does say plus. And so now we have 15 cats and 22 dogs. So that if you can partner up with your neighbor, and you're going to take a moment to just understand polynomials. Using the polynomials and the names below, A, B, C, D, determine the classification scheme. In other words, where do these words come from these expressions right there? So why is this guy here called a cubic binomial? Why is this one called a 5th degree trinomial? So go ahead and look at those, look at their names, and see if you can come up with some sort of scheme. What is the pattern being used? You don't need to write anything down yet, or if you do, do so in pencil, because you might need to make a change. It's been about a minute and a half with you out here. One observation made is we have a cube there, and hence we call this a cubic right there. So notice here that we have trinomials here and trinomials here. And then what we see here is I get 1, 2, and 3 terms, 1, 2, and 3 terms. So as we're seeing, something about the exponent is important, and something about the number of terms is important. So just to back up a little bit and compare this with geometry, notice that if you remember from some geometry days, when you were talking about this type of triangle, we called this one a scalene right triangle. Why is it called scalene? Well, because there are no sides that are the same length, no congruent sides. But down here we have 2 congruent sides, so we called that one isosceles, but because of this big O angle, we called it obtuse. So this is a scalene right triangle, and this was an isosceles obtuse. Well, how were these guys named? This one is about sides, and this is about your angles. This is about sides, and this is about your angle. The key thing on the right triangle is that that's a right angle, and the key thing about the obtuse triangle is that's an obtuse angle. So the same idea is coming along. We're going to name each polynomial by 2 things. Number 1, by its degree. And more specifically, you should write this in, is highest degree. There's a caveat to that in a minute. On the very last one, you'll see that there's going to be a caveat there. And next, as pointed out, is the number of terms. And just so that we might as well throw a definition in there, terms are separated by add and subtract. Terms are separated by plus or minus. All right, let's actually start. Well, we'll start at the top. This one is an interesting one because you can't see the degree, but if you write it in, we have an x there to the power of 0. We have an x, I kind of ghosted it there so it's not permanent, but it's an x to the power of 0. It's this 0 right there that gives it a degree. So it has a degree 0 because the variable, and so more specifically, the highest degree on the variables. And it might be more than one variable. So there is no variable, so it has no degree. So that has a special name. It's simply called a constant. Why? Because it doesn't variate, doesn't change. Next, the hidden exponent that's right here. The hidden exponent is a 1. And we've already been talking about that. That has a 1 right there. So we call that one, well, we'll call that a power of 1 right there. And that has a name called linear. It's my linear term. Next, this guy has a power of 2. The highest exponent is a power of 2. So we call that degree 2, and that has a name called a quadratic. In fact, for the next month and a half, we're going to be spending time in quadratics. Almost all the way to the end of the year, we're going to be talking about focusing on quadratics. Okay, this next part is a little bit tricky because there is a hidden 1 right there with that variable. So what you actually have to do here, and fortunately for us, we're not going to spend a lot of time on this, so we're going to see it just a little bit, but we wanted to point it out to you because it's part of the definition, is that what you actually have to do here is you have to take those two and add them together. Same with this one here. This is an x to the power of 1. This is a y to the power of 1. So this is my second degree right there. But the highest degree is a 3 right there. So that's where we get that. So it's the highest degree on the variables, but you could also add them together. It could be the sum of the variables in a single term. And 3 has a name. It's called cubic. Next one, 4 has a name, and it's the 4th degree. And there are 2 ways to say it. This is the most popular way, is just 4th degree. You don't need to get crazier than that. In fact, after 4th degree, you just say 5th degree, 6th degree, etc. But sometimes you might hear the word quartic. I am not going to make you know quartic. In fact, 4th degree is a good way to say it. And this last one here, if we add those 2 together, we get 2 plus 3 equals 5. So we can simply say 5th degree. You could say quintic or quintic, but for now, we'll just say 5th degree. After that, it's just 6th degree, 7th degree, etc. Now, number of terms, because it has 2 names. Just like this over here as scalene right triangle, we have 2 names here. One of them is based on the degree. So this guy here is called a constant, but by the number of terms. Count the terms here. I see exactly 1. So that has 1 term. So we just call it a monomial. So this one here has exactly 1 term also. This one has 1 term also. So the number of terms is also 1. So it's still a monomial. But its name is this. It is a linear monomial. It's a linear monomial. The quadratic. The quadratic has 1, 2, 3 terms. Because it has 3 terms, we call it a trinomial. And I didn't even write one that has a 2. My error. So I'm going to toss in there one that says 2, and we call it a binomial. But when we finish these ones up here, all of those have, that's a 3, that has a 4, that has a 1. So the 3 is still a trinomial. The 4, we just say polynomial, because after that it just gets too much. So just to show here, this term, this expression right here is a 4th degree polynomial. This one right here is a cubic trinomial. This one down here is a 5th degree monomial, because it only has 1. And you can check your answer here. The next thing we want to consider is what a polynomial is in standard form. In standard form. So, in fact, I will write the answer here, and then I want you to talk about with your neighbor how standard form, how we define standard form. So the answer here is this: 6x to the 4th minus x cubed minus 3x squared plus 7x minus 5. So that's the first part. That's standard form. I haven't classified it yet. But go ahead and talk real quick with your neighbor. How did we get from here to here? It's using the definition. What's the definition of standard form? Go. As we see here, it is important to go in descending order of the exponents. Descending order of the exponent. Descending means to go down, order of the exponents. So we start with the highest exponent here, and notice what we bring along with it. We bring along the sign in the front as well. This is a positive 6x to the 4th, so that's what I wrote first. Don't need to write the plus. Over here, when I got to the quadratic term, I have a minus, so I made sure to bring that minus with me here. It's a negative 3x squared. Good, so that's standard form. Next, we want to classify by its degree and number of terms. That's just what we did before. So this is a 4th degree. I can count the number of terms, but I don't need to because there's so many. We just say polynomial. 4th degree polynomial. Like we did with our warm-up, we were asked to add things together. So if we were asked to add together this trinomial and this binomial, what do we do? Well, there's 2 ways that we're going to approach it. Number 1, you can set it up vertically, just like we did for the warm-up, or you can set it up horizontally. And it's completely up to you, whichever method you prefer. Generally speaking, you won't be quizzed on one particular method or the other. So let's look at the first one here. The first one is this right here. So I say 4x squared plus 2x minus 3. And when I am considering my second term there, my second expression, and when I'm adding it, I have to line up appropriately. Notice there is no blue in my diagram here. I didn't highlight the blue because there is no linear term. There's nothing to the power of 1. So when I carry it down, the next binomial, I'm going to write it here and then put the plus 6 way over here and leave that gap. You don't have to write anything in it. Then I draw my line like we did in the olden days, and I put a plus on the side because that's what I'm doing. I'm adding together. So now we just add down just like we had our ones matched up, our tens place, our hundreds, and our decimals. Same thing here. We're having our constant, our linear, our quadratics. In other words, like terms are lined up. Like terms are lined up. So now let's just finish that up. This one here, Watch the mistake here. 7x 4. That is wrong. Go ahead and tell your neighbor, if you think about it, why that's wrong. This unit here needs to stay the same. This is a 2 here, a 2 here, so this has got to stay 2. Kind of like we did with the 4 cats plus 3 cats is 7 cats. I'm not changing the exponent. I'm not changing the exponent. So if you haven't already written that down, it's important for you to note here that the exponents do not change. The exponents do not change. Let's look at a horizontal method. And the horizontal method is just rewriting exactly what we see, but we use a couple properties, which you may recall, the commutative property, which means I can move things around the addition symbol. And we also say the associative property. I'm going to reassociate things, the associative property. So I'll rewrite the problem down below in colors and then show you how things move around. So I get, here's my original problem, like so. And is the plus here. We do the 3x squared plus the 6. Using the commutative property, you can just rearrange things and group them together. So for example, I can group together my squares like this. My quadratic terms are grouped together. I have only one with a linear term, the 2x. And lastly, I have a plus negative 3 plus 6. Notice that this minus right there, I just made it as a negative. And everything in between is, I'm adding them together. So here I've reassociated them, and the commutative property says I can flip things around. Broop. So these guys here, flipped around, and then I put parentheses around those. This guy flipped around before to over there, and then these guys got flipped here, boop, 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 and now they're grouped together there. So I've used those properties. Now to finish it up, we just combine like terms. So this technically is 7x squared. There is no more linear to combine like terms, and then this here is just 6 minus 3. And there we go, 7x squared plus 2x plus 3. No matter which method you use, you get the same answer. This is just about regrouping, and this one is about lining up my units. Whichever method you prefer is actually what you can do. So take a gander at the try it down below.